He also has published 5 book chapters in research book published by Springer. He has delivered more than 29 invited talks, keynotes in national and international workshops and conferences. He has delivered 9 expert talks in national and international FDP workshop seminar. He has organized 9 research workshops, 2 internships sponsored by DST, 9 webinar or seminars. He has membership of 5 academic bodies. Under his supervision, 4 students awarded PhD. He is founder and president of MathTech Thinking Foundation, a Ministry of Corporate Affairs, Government of India approved NGO. So, welcome, Dr. Mehar sir. Now over to you, sir.
Thank you, sir, for nice introduction, and welcome to all the participants. And first of all, I regret that we have to postpone session for 4 hours due to some unavoidable reason. Many participants are very familiar to us and a regular participant of our events, and some of new. So due to change of this timing or reschedule the event, we understand that some of the participants may have some challenges. In the previous lecture, many things has been covered, and I hope that all these are very helpful to you. And the content which was covered during the past 2 sessions has been uploaded and also provided to all the participants. If still any participant have any challenge or not able to get all this content, you can contact us. So without any loss of time, I'm going to share my screen. Please let me know. I think my screen is visible to all of you.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. And battle window is also there. Both are working properly.
Yes, sir. Yes, sir. It's working.
Okay, thank you. So in this session, actually, I have different slides and which was prepared for symbolic mathematics. Okay, so I am covering the content from those slides. In this slide, we will cover what is symbolic math toolbox product description, and how we can create symbolic numbers, variable, and expressions. Create symbolic variable, how we can create symbolic expression, reuse names of symbolic object, create symbolic functions. So these topics are included in this presentation. First, we need to understand what is symbolic mathematics or symbolic variable. Sometimes like the value of 1/3, if we get that is 0.333 and so on. Okay, but this is not the exact value, that is approximate value. But 1.3 is symbolic expression, which is the exact value. And some more example you can choose. There are so many calculations are required in the calculus, just like we have integrations, derivatives, and solutions of any polynomial like ax square plus bx plus c is equal to 0, which is quadratic equation. And if we want to solve this type of equation, then the root of this equation will be in the form of its coefficient a, b, and c. Okay, so when we solve any kind of a differential equation or we want to integrate or we want to differentiate. Just like you can choose if we have a function y is equal to sine x square. Okay, when we differentiate, that will be also in the form of 2x cos x square. Okay, so this type of calculation can be possible only if we are familiar about the symbolic mathematics and its expressions. So how we can declare all these symbolic expressions and how we can use. So this tool is very helpful, and many differential equations, when we find out the solutions, and then we need to plot these symbolic functions, because when we solve any type of differential equation, the solution will occur always some function, and then after we need to plot the same. Okay, so all these type of calculations for scientific and engineering can be possible while we are using this type of symbolic tool in the symbolic tool of MATLAB, and the expressions and how we can declare the symbolic variables, and then after declaring the symbolic variable, then how we can use. So all these things are very required. So here is the basic introduction about the symbolic math toolbox, and how this symbolic toolbox will help us. It perform symbolic math computations. Symbolic math toolbox provides functions for solving, plotting, and manipulating symbolic math equations. We can create, run, and share symbolic math code using the MATLAB live editor as well as on offline also. The toolbox provides functions in common mathematical areas such as calculus, linear algebra, algebraic and ordinary differential equation, equation simplification, and equation manipulations. So these are the basic areas where we can, this symbolic toolbox will help us for different type of problems, and with the help of this symbolic math toolbox, we can solve various type of the problems which are involving symbolic expressions. And here are some key features for the symbolic mathematics. First is symbolic integration, differentiation, transforms, and linear algebra. Then we have algebraic and ordinary differential equation solvers. There are some inbuilt solvers in the MATLAB, and we can also write the code to solve the different type of differential equations by using symbolic expression. Then simplification and manipulation of the symbolic expressions. Unit system of specifying, converting, and computing using SI, US, and custom unit system. And plotting of analytic function in 2D and 3D. We can easily use symbolic expressions for the plotting also. And last one, we have the symbolic expression conversions is to MATLAB, Symbolic, Simscape, C, Fortran, and LaTeX code also. So these expressions also we can convert in the LaTeX while writing the or preparing the document. Okay, in the C and Fortran also. So here is how we can create a symbolic number. Okay, we can create a symbolic number by using sim, which you can see here, the sim function. By using this function, we can create the symbolic number, and also we can declare the variable by using the sims. Okay, so symbolic number are exact representation, unlike floating point number. Create the symbolic number by using the sim and compare it to the same floating number. Yes. So here you can see sim 1/3, and we can compare here the values. If you will enter here 1/3, and the value of 1/3 is 0.333 and 3. Okay. And if you are using here sim 1/3 and then enter. Okay, so this will return the exact value, the same value. Okay, so this is the symbolic expression. So whenever we need the exact solution, in that case, we need to declare the symbolic number, symbolic integer, and symbolic variable so that we can have the exact solution. If you are choosing this value, which is not the exact value or not equal to 1.3, but this is the approximate value to the 4 decimal places only. Okay, so this may affect our result when we are using in the place of 1.3, 0.333 and 3. Okay, so if you are using the symbolic number, then this will help us to find the exact solution in our findings. So here is also we have a sim square root 29. This is the one more example, and we can compare here. If you are using SQRT, SQRT is the inbuilt function in the MATLAB, and by using this expression we can find out the square root of any number, and here we are choosing 29, but it is returning 5.3852. Okay, this is the approximate solution for the value of this expression. Okay, and if in this place you are using sim, if you are using sim, okay, and see, this is 29 exponent 1/2, or you can use in the place of at this place pretty function. Pretty function is there for ANS. This is the output value. Okay, see here. So when you will use the pretty function, this will return the same as we have the input value. Okay, so this is the exact value. And for the same, you can use, if we are using here 25, and see, we know that 25, this is a perfect square value. That's why the square root of 25 will be 5, and it's a symbolic number value will be, again, we have 5. Okay, so only when we have the exact number, that will return us, and if the value is in the floating form, then the value will remain the same. Okay, so these are the symbolic numbers. The symbolic numbers is represented in the exact rational form, while the floating point number is decimal approximation. The symbolic result is not indented, while the standard MATLAB result is indented. So here we have the calculation on symbolic numbers. We can choose here the example of sim pi. Okay, so these two expressions we are using. Calculations on symbolic numbers are exact. Demonstrate this exactness by finding sin pi symbolically and numerically. The symbolic result is exact, while the numeric result is approximation. You can try in the MATLAB and see what will be the change there. Here we are using first time sin pi, and when you will use sin pi at this place, and see, this is this value. Okay, and when you are using sin sim pi, okay, same and pi, and then enter. So see the difference. So we know sin pi is 0, but in the case we have this value. Okay, why this happen? Because at this place pi is, the value of pi is, this is the value of pi in the floating. Okay, that's why we have this value. But if you are using sim pi, then you have this value. Okay, CLC, along with the, I would like it to let you know, there are so many inbuilt MATLAB functions. Okay, and all these are known as elementary functions. Okay, so you can use the help elementary function. When you will enter this statement, all the elementary functions, which are also again inbuilt function in the MATLAB, this will help you in throughout all the use of MATLAB, because we must be familiar all the expressions which are required for the MATLAB, how we can input, or how what are the statement and how the functions are defined in the MATLAB. Okay, so once you must go through all these inbuilt elementary functions, or whether you are doing in the solving the problems which are associated with engineering or scientific computing or other branch of sciences. But if you are familiar with all the elementary functions in MATLAB, then this will help you in many ways. So when you will enter this statement, help elementary function, okay, and enter. So this will provide us the list of entire elementary functions in the MATLAB. Yes, now you can see all the elementary functions are here. Okay, and one more thing. Good evening, all of you. There are some participants who are attending the session on the YouTube channel also, and I welcome to all the participants who are attending the session through the live streaming. So here are the list of all the elementary functions. Okay, so the one more thing, when you are using without knowing the expression, okay, the value of sine pi, when you will enter here value of sine pi, okay, this will not, this will be this value, okay, and also we know that the value of sine 0, the sine 0 must be equal to, sine 0 must be equal to, anyone, can you please let me know? Anyone? Okay, first I'd like to let you know, you need to permission to unmute your mic. So now all the participants, whenever you have any question during my presentation, you can ask the question. Now you can unmute your mic. I want to know what is the value of this expression. Sine 0.
Sir, it will be 0.
0.
Sine 0 is 0.
0.
Great. Okay. And but sine pi is not equal to 0. Okay. So, and in the same way, cos 0.
1.
1. Okay. So just 1 minute. CLC and clear. CLC. Sine 0. And sine pi. Okay. So now I am going to enter the again CLC and help elementary function. Okay. So come here. So here, when you will click on it, this will come to address place. And here are the information about the use of function, how you can use these functions. Okay. So here will return the sign of argument is in radian. Okay. And if you need to enter in degree, then you will use this expression sine d. Okay. So in this case, the argument will be in degrees. So you can use this one, sine d. And here, when I will enter pi, this will return this value. And here are some few examples. The value of n, you can have 1 or 2. But you can use degree. For the degree, you have to enter at the place d. And then enter. Okay. So these are the values, and you can use for Here are the examples which you can use easily. Okay, corresponding to age. And if you need the inverse value, then you have a sign. Okay, a sign will return the inverse sign and result in radian. Okay, so in this way you have all the expressions with example and how you can use in the MATLAB. So all the elementary functions are here. If you need to use for log value, log 10, when you will click on it, yes. So here are the examples how you can use. You can use this expression in this way. This is the syntax in the MATLAB to use. Okay, so if you will use here and you want to find out the value of 100, and when you will enter, this will be 2. Okay, so once you must be go through all the elementary functions so that whenever you need to use for your computing part, this will help you. So come back to our presentation. Here we have now the symbolic variables, how we can create the symbolic variable and then how we can use. So we can easily create the symbolic variable using either sims. We can use sims function or we can use sim. Typically use of these functions. So sim, how we can use sim or how we can use sims. Sim create a numbered symbolic variable or create symbolic variable in the MATLAB function. So sometimes when you are writing some type of function or user-defined functions and you need a variable during that time, you can use sim and you can create one variable according to your requirement during the writing the function. And sims create a fresh symbolic variable for interactive symbolic workflow, that is for symbolic variable creation in the MATLAB command line or in the MATLAB live script. A fresh symbolic variable does not have any assumption. Just like you can see, either you can use sims. So here, by using this statement, you can declare one variable, two variable, three variable, whatever you need for your computing. And the another way to declare the variable is this statement, y is equal to same, and in the code sign we will use single quote sign y. So here when you will use this second statement, the y will be symbolic variable. So either when you are using creating some function, okay, in that case if you need some symbolic variable, then you can declare this one, or in the beginning or the fresh when you are going to start, during that you can use sims. So there are different use of these sims or sim function. Okay, the first command creates the symbolic variable in the MATLAB workspace with the value x assigned to the variable x, and the second command creates a symbolic variable y with the value y. And in the same way, you can create the symbolic number also whenever you need. See here, we are using, if you need multiple variable, okay, in one command, you can declare by using sims a, b, c. Okay, and here is the example how we can use these multiple variable, and also if you need multiple more than 3 or 5 or up to 20, then you can use this statement. Here you can see a is equal to same double quote a comma 1 to 20. So when you will execute this statement in the MATLAB, okay, this will return a is equal to a1, a2, a3, and these are 20 symbolic variables. These will be declared. Okay, you can check in the MATLAB. You can have a is equal to, you can have a is equal to sim, and then in the quote sign we have is a, then comma, and here is 1 to 20. Okay, and then enter. So here you can see. So these are multiple symbolic variables. Okay, so according to your desire, your need, you can by using this single statement, you can generate multiple symbolic variables. Okay, and then after there are some statements like who. By using this who statement, this will return all the variables which are used in our workspace. Okay, so here there are only two variables. So this will return how many variables are used in the workspace. If you will use whose, so this will return more information about the used variable in the workspace. So in the first column, you can see these are the variable A and answer, then corresponding the size of this variable. Okay, byte size, class, attribute. So these some more information will return by using these two statement, who and whose. Sometimes if you need to check the variable while computing or while doing some calculations. Okay. So here, this has been done. We will not repeat the same. Yes. So the sims command is convenient shorthand for the sim syntax, and it is typical to use is to create fresh symbolic variable for interactive symbolic workflow. So the use of sim syntax to create the following symbolic variable in the MATLAB function, many numbered symbolic variable whose value differ from its name in the MATLAB workspace, symbolic numbers such as sim5, and symbolic variables that inherits the assumption from a previous used symbolic variable having the same name. Okay, so these are the uses of the sim function, and here we can find the some application, and just 1 minute, please. So here we have the phi, which is the golden ratio, and 1 minute, please. Okay. Yeah, pick that. Yes. Yeah. So here we have, this is the golden ratio, and the command we have phi is equal to 1 plus square root sim phi, and this is the symbolic number. Okay, upon to this expression we can give the input statement for the above golden ratio function in this way. So this will return the value when we will enter in the MATLAB. And now we can perform the mathematical operation, like for example, phi is equal to, f is equal to, we have, this is the function, phi square minus phi minus 1. Okay, so when you will pass this, this value will be passed at this place. Okay, so this is the first statement in the MATLAB. Then after, we are using this statement, and when you will enter this statement, this value will pass at this place and at this place. Okay, this will be the argument for this function. So when you will enter this statement in the MATLAB, this is the returning value in the MATLAB. Okay, so this will not simplify the expression. This will return the exact value because of this symbolic expression. If we have at this place 25, then this will be 5 and this will simplify. Okay, but here 5 is not the perfect square. Okay, that's why we have the above expression in the symbolic expression, not in the simplified. Further, if you need to simplify this expression, we can use some inbuilt function, which we will discuss later. Okay, so in this way, you can use the symbolic expression for the symbolic computing or the calculations. And here is one more example which you can see. We have the quadratic equation, and in this quadratic equation, we have A, B, and C. These are some parameters. X is the variable. And if you want to write this equation in the MATLAB, okay, then how it can be possible? You have to first declare the all these parameters along with the variable. So first you will declare in the MATLAB, since A, B, C, and X, then you can write f is equal to this polynomial or this expression for the further simplification or the computing for your use. Okay. So to create the symbolic number, use the sim, and do not use the sims function to create the symbolic expression, that is constant. So here you can check in the MATLAB also. If you want to write a function y is equal to sine x, you have the function y is equal to sine x, and when you will enter, this error will occur. Okay, if you want to write any polynomial, f is equal to ax square plus bx and plus c. Not possible. Okay, then what you will do, CLC. So you will use sims A, B, C, X, Y, the variables or the parameters which are required for the expression, you will write in this way. Then you can use, and you can write the functions also. Okay, so here we have G is equal to sine x. You can write now this function. You can define, no error. Okay, f is equal to, you have a product x square plus b product x plus c, and you can see that there is no error now. F equal to, okay, so this is the use of the symbolic variable, because if you need to instruct the MATLAB, that will be in the proper expression and readable for the MATLAB, only then you can use for your different type of symbolic computing. So first you need to declare the variables and the parameters which are required for your task. Only then you can perform different type of operations. So here you can see we have sims A, B, and f is equal to a plus b. When you will enter f equal to a plus b, this will return a plus b. Okay, and you can perform different type of operations on these expressions. If later you will enter f, sims f. Okay, see once again, we discuss everything, but here once again you need to let you know, sims we have a and b, and if we have f is equal to a plus b and enter. Okay, again if you are doing here sims f, and then when you will enter f, see the difference. So in the previously we are using here a b, and then we operate f equal to a plus b, and this will return some function. Okay, this is the assignment to f. Now again, if you will declare the same expression which we use at its place, sims f. Okay, so this will consider new value, new expression. This value will not repeat at its place. So when you will declare whenever, this will consider the present or the new value. Okay, so this value to the f will not be taken at this place when you will declare here, but the value of this is already stored in the workspace. So the latest value will be taken here. Now by using the same, we can create symbolic function. Okay, and 2 variable, 3 variable, and if your functions are involving some parameters, okay, along with the variable, you can extend. So this is very quite simple. So symbolic function represent math function. Use symbolic function for differentiation, integration, solving ODE, and the other math operations. Create symbolic function by using sims. So here you can see the example how we can use for function. Here you can see sims f x comma y. So this is the function. Okay, and after declaring the function involving the variable, you can write the mathematical expression. See here, f x comma y is equal to x square product y. Okay, and this will return this value. So this function has been created of 2 variable, and you can pass the value 3 to corresponding to x and y. And also when we will create this type of function, you can differentiate, you can integrate of any order, and we will do later by using these expressions. Okay, now you can check in the MATLAB also. Sims f, and here you will take x comma y. Okay, and enter. Then you can write a function fxy x comma y is equal to, I am taking here sine x square plus y square. Then divide x plus y. So the function has been created. Now you can pass any value. Now you can pass any value, and also you can use pretty function for this also, as I do previously. Okay, so if you want to pass the value for this function, you can do f. I am taking here 3 and 2. We have this value. We have sine 13 upon 5. Okay. And if you will take one value, if we will choose 0, 0, if we take 0, 0, and then enter. Many errors are there. Division is by 0. Okay, so numerator is also 0 and denominator is also 0. This is not possible. Okay, so here you can take f 2 comma 0 sine 4 by 2 CLC. So in this way you can use the function and you can easily create the symbolic function and you can do various operations. So this one slide is over. Now I am opening the next slide. Just 1 minute. We have yes. Yes. So this slide will include create symbolic function we have discussed already and symbolic matrix, but we will focus on perform symbolic computations which will involve derivative, integrate symbolic expression, solve the equations, simplify symbolic expression, substitution in symbolic expression, plot symbolic function. Okay, so these areas we will cover here in this slide. So here, this is the, I think, same example. We can skip this one. Yes, here you can see symbolic functions accept array input. Here you can see x variable is equal to 1 to 5. This is the array input, 1 to 5. And y variable we have is 3 to 7. You can check it. Okay. What we are doing here, we are passing these two arrays through the function. The function is created at this place, which we have used in our MATLAB command window. Fx y is equal to x square product y. Okay. In this example, we just pass the value of x, we have 3, and that of y is 2, which will be 18. But you can pass the array. So here you can see x variable is 1 to 5, y variable we have is 3 to 7. Okay, and these variables in the array input, you can pass through this function which we defined, f x variable comma y variable. So all these array input will pass through this one, and all these will return these values which you can see at this place. So you will try yourself. This content will be provided you after this session. Okay, so very quite simple. You can pass the array input through this function after creating 2 variable or 3 variable or 1 variable, depend upon your problem. Okay, so now how we can integrate? How we can integrate all these? So you can integrate and you can differentiate symbolic functions and integrate and or simplify them, substituting the argument with values and perform the other mathematical operations. For example, we have dfx. Okay, diff is inbuilt function in the MATLAB, and f is the function which we create here. Okay, and comma x means we are differentiating f with respect to x. See in the MATLAB. So what I am doing, I am creating here new script file control plus N, and this will open. First, you need to save this file, okay? And symbolic, this is a symbolic calculus, okay? And save it. So what we do, we are using here CLC and clear, okay? Then sims. Here is F, then we have X comma Y, okay? And Fxy, we are choosing here is equal to, we are taking the same function here so that you can compare, and Fxy is equal to X square product Y, X square product Y, and suppress it, okay? Now, if you want to differentiate this expression, so what you will do, you will use diff function. Diff is inbuilt function in the MATLAB to differentiate, okay? So here we have is diff x. Diff x is equal to diff, this is diff f comma x, f comma x, okay? And then now we can execute these sequence of statement and we can check the value. Also, you can use here display function for dfx, okay? Now check the value. Yes, so here you can see the derivative of this expression we have is 2xy, and also saying that symbolic function input x and y are the symbolic input, which you can later pass these values for this function as well as for the derivative. So this is f is function of two variable. F is function of two variable, okay? And if you are using this statement, the meaning of this one is partial derivative of f with respect to x, okay? If you are choosing here y, so this will be the partial derivative of f with respect to y. And if you want to display the result, you can use display dfy. And now you can execute the statement. Now you have two values. So this is the first solution, which is corresponding to this statement. And this value is corresponding to this input, okay? And in the both cases, xy will be inputs, symbolic input, okay? So here y is single y, but here is x square. So when you will take the derivative with respect to y, and y derivative of y will be 1, that's why we have only x square. Calculate diff x y, 8x is equal to y plus 1. Okay, so what you will do, df, okay? So what we do, we will put x is equal to y plus 1. That is very simple. We have df x, and here y is equal to, we have is x plus 1, and comma y. The value is x equal to y plus 1, sorry. X equal to y plus 1. And here is y. And when you will execute, So this value changed. This value changed. You can comment this statement by Control R. Control R is used to for the comment. Okay. So just you need to select the statement and then press Control plus R. So this statement will not work now. Yes. So this is the value corresponding to this one when you will put x is equal to y plus 1. Okay. And if you will change this value in the place of y, we are doing x plus 1. And run this file. So this is new value. Okay. So after differentiating the value, you can pass the any value, you can play with the code, and you can do several experiments according to your requirement, to your understanding, your calculations. So here you can see the symbolic matrix. Okay. And very quite simple. Same is equal to ABC, and A is equal to, we have, this is the matrix ABC in the first row. In the second row, CAB. In the third row, we have BCA. Okay. Also, you can create the script by using here double percentage symbolic matrix. Okay. This is the symbolic matrix. And the same you will use here clear. You will use here CLC and clear. Okay. Seems we are taking A, B, and C. Then A is equal to, we have is matrix. In the first row, we have A space B space C. This is the first row. Then semicolon will break the row and start the new row. Okay. Then we have ABC, then BCA, B, C, A, break the row, then CAB, C, A, and B. Okay. Yes. So one more thing which must be, which will be very useful. When I will remove this semicolon, you can see this equal sign highlighted, and on the right hand side at the place you can see the warning. It means the statement is correct, but not in a proper way. If you will use the at the place semicolon, you can see that here the sign is green. Okay, so you can avoid the warnings, and you must understand all these basics so that when you will write your code, a beautiful code, so these very small things will help you. And if you want to print this value, then you will use display function. You will use display function in the script file. Okay, and now you can see that still the sign on the right hand side is green. And now if you want to run this cell only, then what you will do, your cursor must be in this cell and then press here. And this is the matrix. This is the matrix. Okay, in the first row we have is ABC, then BCA, CAB. Okay. So if you want to find out the sum of the first row element, so this statement, when you will give the input sum A1, colon. Okay. So you can understand about the expressions. You can use the meaning of A, 1, comma, and colon. Okay, when you will enter, this will be first row ABC. Okay, if you will use sum function will add all the element. Okay, you can see A plus B plus C. And the same statement you can use here. Okay, and now you can run the code. Yes, you can see this is the matrix, and the sum of the first row we have is A plus B plus C. Okay, and if you will do, here is colon, and here is 1. Then we have the same sum. You can do here 3, and again run, the value is same. Okay. So here we to check if the sum of the element of the first row equal to the sum of the elements of the second column, use is always. This is the is always function in the MATLAB. For the comparison, we can use for the comparison whether the left hand side is equal to the right hand side. You will use is always. Okay. So here is always, then sum of first row element, double equal sign is used for the logical statement. Okay. Sum A colon comma 2, sum of the second column and sum of the element of first row. Are these equal? So when you will execute this statement, the logical value is 1. It means this is true. Okay. What are the logical statement or the expressions? CLC, you can check here. Okay, we know 5 is equal to 5. 5 is equal to 5. So when you will enter, logical answer is 1. It means this statement is true. Okay, and if you are using five is equal to 6 and then enter, returning 0, it means this statement is false. Okay, if you are using 5 is less than and equal to, this is less than and equal to 6, then also the logical statement is true. Either 5 will be less than 6 or will be equal to 6. Okay, so one condition is true. That's why we have the logical answer is 1. The above statement is true. If you have 5 is greater than and equal to 9, okay, that is 0. 5 cannot be greater than 9 and cannot be equal to 0, equal to 9. That's why this statement is false. Okay, and if you will change this value, then is true. And also this statement will be true for 5. Okay, because two conditions are there. So one statement will be true. So corresponding to that, we have the answer. And this is also the logical expression, less than or greater than. Okay, CLC. So these expressions are required in the computing part and must be very familiar. And we will provide all the content which are we are presenting here, so that this can be very helpful to all of you. Okay, you can try this statement. Is always sum is equal to this one, and this will be true. And also, you can generate the element while creating a matrix. Okay, in the matrix also you can create symbolic by using the symbolic element. And the expression we have is A is equal to same, and this is the matrix A. This is 2 by 4. This is 2 by 4, 2 rows and 4 columns. So when you will execute this statement and give the input in the MATLAB, this will return this value. So the first line is the input, and the second we have the output value in the MATLAB. But here you can control the format of the generated names of the matrix by using %d in the MATLAB. Okay, A is equal to, when you will use this expression same cosine A percentage D. Okay. And close the cosine, comma, 2, 4. So when you will give this input in the statement in the MATLAB, then this will return this matrix A11, A12, A13, A14, A21, A22, A23, A24 by using this statement. You can manipulate these numbers for different order of the matrices. Okay. A particularly effective use of the same is to convert a matrix from numeric to symbolic form. And the command is, this is the Hilbert matrix. This is the Hilbert matrix. And the values will lie between 0 to 1 in this matrix. Okay. And you can generate the formula for the same we have is so the formula is sorry. Okay. So Aij will be equal to 1 upon I plus j plus minus 1. So this is the formula to generate the Hilbert matrix for this one. Okay. So if you have this matrix is 3 by 3 order. So the values of this matrix will be if you want to get this element. So this is A11. So A11 will be equal to 1 upon 1 plus 1 minus 1. That's why this will be equal to 1. And if you want to get this value, so this will be A12, 1 upon 1 plus 2 minus 1 is equal to 1 by 2. Okay. And so on. So by using this expression, you can generate Hilbert matrix according to the order of the matrix. Okay. So now, if you just give the input in the MATLAB, A is equal to help. This is the inbuilt function in the MATLAB. You can check here. You can check here. You can check here. Hilbert matrix. Okay. And A is equal to help 3 and semicolon, then display A. Okay. And now run. Now run. You can see this is the matrix. Okay. But here you can see if you will use sim to A, like just like in this way, A is equal to sim A, then all the values will be converted in the symbolic expression of 3 by 3 order, and these will be the values. You can see. You can see A is equal to sim A. Display A. Okay, we have two statements now. Yes. You can see. This is the corresponding to the first statement. Okay. And this is by using the symbolic expression. So when you will use the symbolic sim function, this will convert the values in the symbolic expression. So all these elements in this matrix are symbolic. If you are taking at this place 4, now you can see this will be the 4 by 4 order matrix. Matrix will be 4 by 4 order. Now come to here we have the differentiation, symbolic expression, integration, solve equation. So all these we will discuss one by one. So here we are choosing very simple example and one variable. Okay. So here f is equal to sine x square, and either you can use this expression diff f, or you can use diff f comma x. Okay. By default, when you will use the first statement and sometimes the function is containing two variable or three variable, this will take always the first variable by default. Okay. And otherwise you have to use this expression for the particular variable. So here you can create the script file for derivative. Okay, we are taking here sims. You can take x and y both. Okay, so f is equal to, we have is, you can take any example. We are taking sine x square and suppress it. Either you can use diff f, okay. So this will return the derivative of the above expression. You can check it. And before that, you can use CLC and clear also. CLC is used for the clear the command window. Clear is used for the variable. So here, this is the derivative of this function. Okay. Or either you can use this expression diff f comma x. Okay. So this will return also the derivative. But sometimes if you need the second order or third order, then what you will do, you can use here 2. Okay. This will return the second order derivative. I will comment these two this statement. Control R. Okay, see. This is the second order derivative. If you will put at its place 5, this will return the fifth order derivative. This is the fifth order derivative for this function. Okay. For the higher order, you can use this expression. If you have a two variable function, you can use for the two variable also. Okay. So here you can take f is function of two variable. So I am taking two variable function like sine x square product cosine x square. Okay. Now here we have both x and y. And when you will use this one, here we need y. Okay. And the symbolic variable we have already declared at this place. And when you will use this statement, this will differentiate this function with respect to x only. We have this answer. Okay. And if you are using here y, then this will differentiate with respect to y. This is the derivative with respect to y. Okay. And if you are using y second order or third order, you can do also. So this is the second order partial derivative of this expression with respect to y. Okay. And if you will take 5, you can choose any order. You can choose any order. Say it is 10. Okay. So you can play this code. So here we have this part discussed. This also has been discussed. Okay. So here we have this expression, and what we are doing here in the first bracket, which I am doing highlight at space. See carefully. We have this function only f is equal to sine x square. Okay. Then we have cosine y square. So when you will take the first order derivative with respect to y, then again we are taking the derivative of this expression with respect to x. Okay. So this will return zero value. First you are differentiating with respect to y, then you are differentiating with respect to x, and hence the value will be 0. Any question, please? If you have any question. So here, how we can integrate any function? Very simple expressions are there. Here we are doing for one variable, indefinite integral. F is equal to, we have is sine x square. Okay, x is a symbolic variable. If you want to integrate, then we have the int is inbuilt function in the MATLAB for integration. So int f, this will return the integration of this expression, which will be x by 2 minus sine 2x by 4. Okay, and you can try in the MATLAB also. Here is integration, and same x. Okay, and f is equal to, we have is any function you can take sine x square. Okay, suppress it by using this one, and then int f, and run the code. So this is the integration of this expression, but also use here CLC and clear. Okay, see. Here we have is, if the expression depends on multiple symbolic variable, you can designate a variable of integration. For example, we have sims x, y, n. F is equal to, we have is x raised to power n plus y raised to power n. You can do int f or int f with x. So here what you will do, you will integrate with respect to x, with respect to y, with respect to n. Okay. So when you will take here, we are taking the example here. If you have is f is equal to, symbolic variables are x, y, and n. Okay. And here we have is x raised to power n plus y raised to power n. Okay. And then int f. If you will use int f, see, we have the integration with respect to x, or if you are using here f comma x, then also we have the same answer. You can see we have the same answer. If you are taking here y, then this will be integration with respect to y. Okay. If you are taking at space n, then this will be integration with respect to n. Okay. So whatever you have the variable and parameter, you can do with respect to all the declared symbolic variable. Okay. Please let me know if you have any question during this discussion. Okay, screen is visible. Good evening. How can I export output from command window to Word environment? Very interesting question. I never do this part. I never do. And I don't know whether it is possible or not. But MATLAB syntax are different. But the syntax which you are using in the MATLAB and the presentation you can see here is by using LaTeX. Okay. So this is in the PDF format, the presentation by using the LaTeX software. So now if you have, this part has been discussed. Yes. So if you have definite integral, this is also possible. You can see we have int f 1 to 10. Okay. So this is the lower limit and 10 is the upper limit. Lower limit is 1 and upper limit is 10. So you can do the definite integration also. Integration f and int f comma 1 comma 10. Okay. So here add space you will use 1 comma 10 and see this answer. Okay. But you can choose here a very simple example. You can take add space sine x. Okay. We are taking sine x. And you can use here 0 to pi. We are taking here 0 to pi. Pi by 2. We are taking here 0 to pi by 2. This value. Okay, so for the definite integral, you can use this expression. F is the function to be integrate, and then we have the lower limit and upper limit for the integration. Here we can solve different type of the expressions by using symbolic expression. Okay, so we can solve the different type of symbolic equations, including algebraic with one symbolic variable, algebraic equation with several symbolic variable, system of algebraic equations. So here are the example and how you can do. See carefully. Okay. So we have less time and we can easily cover the content. Yeah. So this equal sign is used for the equal. Okay. If you are using single equal sign, the meaning single equal is used for assignment. Single equal sign is used for to assign the value. Okay. Suppose we have a is equal to 5. The value of a is 5. But if you have any equation, for the equation, we will use double equal sign. So left side is equal to right side. Okay. Then we can call the solve function. Yes, you can see the equation is in symbolic variable x and we want to solve. The equation we have is x cube minus 6x square is equal to, the meaning of double equal is equal to. Okay. This is the right hand side. 6 minus 11x. And we want to solve this equation. So just you will write the equation and you will use this solve function. Solve and then put the equation inside as argument. Okay. So this will automatically solve the equation and return the values. So this is the solution. This is the solution in the MATLAB. Okay, the syntax which are appearing here is the same syntax which we can use in the MATLAB. So you can see the difference between the colors. Okay, so that you can easily understand which part is MATLAB code and which are the text. And similarly, if you are not using the equal sign, what you will do, we can rewrite this equation like x cube minus 6x square plus 11x minus 6 is equal to 0. If the equation, you can rewrite this equation in this way, and you can take only this part and see at the place x cube minus 6x square plus 11x minus 6 and solve. So here we are not using this equal sign. Okay, so this will also return the same answer, no difference. So either you can use the first part or you can use the second part. Here is also sometimes we have the equations involving variable and parameters, and sometimes we need to solve some specific variable. Okay, see, here we are taking two variables and x and y. We have this equation which is 6x square minus 6x square y plus xy square minus xy plus y cube minus y square is equal to 0. Okay, but we want to solve this equation for y, comma y. It means this will return the solution for y. So these are the values for y. Okay, if you want to solve this equation for x, just put at its place x. Okay, so we need to specify for what we want to find out the solution. If see here, if you do not specify any variable, you get the solution of the equation for the alphabetically closest to x variable. Okay, so when you will not use any at the place, this will solve automatically for x. You can do and you can try and do some experiment by using this type of the equations. Sometimes we have the system of equations that is also very quite simple. Here we have, these are the x, y, z, three equations are there, and three values. These are symbolic variables. Okay, so this is the first equation, which is z equal to 4x. This is the second equation, x equal to y. This is the third equation, z equal to x square plus y square. But we want to find out the solution of this system of equation. So very simple, all the equations are separated by comma and use the solve function. But the solutions which we will get must be stored or corresponding to the xyz variable. Okay, so here this we will put equal to this expression x comma y comma z. So these are the output values, or these are the answers corresponding to this equation, a system of equations, or these are the unknowns. Okay, so when you will execute this statement, when you will run this statement, you will have the answers. For x, you will have 0 and 2. For y, you will have 0 and 2. And for that of z, we have 0 and 8. So these are the solutions for this system of equation. You can manipulate the values. You can manipulate the equations. Okay, you can choose more equations in different way. Okay, so in this way, you can solve any type of system of equations by using this solve function. And the input and the syntax is very quite simple. This is the example of the same golden ratio which we discussed in the very beginning. Okay, phi is equal to 1 plus square root sim 5 upon 2, and f is the function. This will return in the symbolic form. But if you want to simplify, you can use the simplify function. You have the simplify function. So here simplify f, this will return the solution after simplifying. And this will be the very simple answer, will be equal to 0. Okay. So symbolic simplification is not always so straightforward. There is no universal simplification function because the meaning of the simplest representation of the symbolic expression cannot be defined clearly. Okay, so all these depend upon our choice, which way is more accurate for our problem. So according to that, we have to decide, we have to choose. Here we have the simplify function, which you can see. For more example, f is equal to, you can see very long function is here. Okay, and first is x square minus 1. Then we have x raised to power 4, x cube, x square plus x plus 1 product, x4 minus x cube plus x square minus x. So you can use expand function. So this will expand the above expression, and when you will use expand, this will return x raised to power 10 minus 1. Okay. So if you will use at this place simplify function for this one, this may be return the same value, but sometimes note, because as we discussed, note the appropriate rule in the MATLAB. So that's why we need to check which expression is appropriate for our problem. According to that, we will use. Here is also we have factor function is there in the MATLAB. We have the factor function. Okay, so this shows the polynomial root. If a polynomial cannot be factored over the rational number, the output of the factor function is the standard polynomial form. For example, you can see here is x cube, 6x square, 11x plus 6. And when you will use factor function here, this will return all possible factor of this expression. So the factors of this expression we have is x plus 3, x plus 2, x plus 1. So just you need to put this equation. If the factor of this equation will are not possible, okay, so this will return the same equation. Input will be the same, input and output will be same if the factors are not possible. Otherwise, this will return all the possible factors. As you can see here, this is the cubic, and hence we have 3 factors, and x is equal to -3, -2, and -1. These will be the values of x, or the answer of this polynomial, cubic polynomial. Here also we have the 2 expressions. H is equal to x5, x4, x cube, x square plus x. And you can use Horner function. Okay, this will convert this expression in the form of Horner expression. You can see here. So when you will enter this statement, the above expression will be converted in this form if it is required for your problem. So all these calculations and computing are very simple to use. Okay. So there is a subs function, how we can substitute the symbolic value with the numbers, and we can substitute a symbolic variable with the numerical value by using the subs function. For example, we have f is equal to, we have is f equal to 2x square minus 3x, 2x square minus 3x plus 1. And x is a symbolic variable subs. This will substitute the value for x. Okay. So when you will use subs function is f comma 1 by 3. This is the value of x. So when you will execute this statement, this is the answer in the MATLAB. So at the place of 1 by 3 will pass through this function. And after simplifying, we have this value. Okay. Here is also one more example. Here is, sorry. Here are two variables. So whenever expressions contain more than one variable, we can specify the value for which we want to make the substitution. For example, we have x is equal to 3, and the symbolic variables are x and y. Okay, and f is this expression, x square y plus 5 x square root y. Okay, so when you will substitute or you put this statement, the meaning of this statement is, for this expression f, we assign the value x, we assign the value of x is 3. Okay, this is the value of x. So in this expression, you can see when this code is run, you can see the value of x has been passed through this function, and this answer will be returned, but the value of y we do not assign. Okay, if you will assign for the y also, then this will be the numerical result. But here we include y variable also. So in this way, you can specify the value for one specific variable. And here is also the same, one more expression is there. For y, we are using x. In the place of y, we have x. Okay, so when the meaning of this one is y is equal to x. So then when you will substitute this value and run these three statements of the code, this will return the answer, which is x cube plus 5 x raised to power 3 by 2. And substitute a matrix into polynomial. This is also possible. Okay, sometimes we have a matrix and you want to pass, or you want to substitute this matrix in the polynomial. So this also you can see in this example, we have, this is the polynomial x cube, 15x square, 24x plus 350. And we have is this matrix. In the first row, we have element 1, 2, 3, and second row we have is 4, 5, 6. So we want to pass this matrix in the above polynomial, and that is also very quite simple. Subs f comma a. So when you will run these three statements, okay, the answer is, you can see 312, 250, 170, and in the second row 78, minus 20, minus 118. Okay, the order of this polynomial corresponding, this matrix corresponding to the polynomial as well as the matrix will be same. So both the matrix have same order. So you can pass or you can substitute the matrix in the polynomial also by using this expression only. Very simple. So here are some f float. Okay. Okay. Just we need to come back in the MATLAB. I have prepared some script file. Yes. CLC. F plot function. F plot. So f plot is the simplest function, and without giving any input or without defining any dimension, or range for the x input, we can plot the function by using sin x. Okay, so here you can see we give only this simple input. We give here f plot sin x, which is the simplest way. Okay, so here all type of the functions we need to require it to define the symbolic variable, and if you have the defined, then also you can use this f plot for the symbolic expressions also. Okay, and if you want to give now the you can do grid on. So grids are there in the inside the graph. Okay, if you want to assign x label, this is x axis. Sorry, this is missing. So now you can see x label is there. Then we have y label. Okay, and on the y label we have is sin x. You can use here sin x. Okay, and you can see on the y label. On the x-axis we have x-axis. On the y-axis we have sin function. Okay, if you want to insert the title, you can assign the title also for the same. If you want to export this graph, how you can do? If you want to export, very simple, Control S. Then this is figure 1. This is figure 1. .jpg. Control S. Okay. So now you when you will come back in the MATLAB and the current directory, and you can see that the graph which we plot saved in our current directory. Okay, if you want to open this one, you have to go in the folder. These are the MATLAB code, and this is inside the calculus, and here this is the graph. When you will double click on it, this will open. So this graph is in JPG format. Okay, you can save in other formats also. You can save the graphs in other format. This is the MATLAB, and again use here CLC. Okay, so now this file is symbolic polymerase. So all the equations which we discussed are here. So here you can see we have same xy, and but in these two equations you can see y is not used, and you can see here there is warning is because for this y, and when I will do remove this y, then the sign is now perfect green. Okay, warning has been removed. If you want to run this one, and you can compare, we have the simplify function, and you can execute from this place. So the answer corresponding to first statement we have is x plus 1, and corresponding to the second statement we have is x raised to power 12 minus 1. Here also we have the trigonometric functions. Okay, and by using by using simplify, we can solve all type of the trigonometric functions and the equations also. Okay, so here we have two expressions, and by using simplify, we can get the value. So corresponding to first value, first equation we have is 1, and for the second we have is cosine 2x. Similarly, here you can find there are three functions are there, f1, f2, and f3, and we are using simplify function for the same. So in the first we have is sin x product, exponential function of x and product exponential function of y. And in the second we have is exponential x minus exponential x by 2 square. And in the third expression we have is log x plus log sim 3 minus log 3x, then plus exponential x minus 1 by exponential x by 2 plus 1. So these three expressions are there, and when we will run the code to simplify, you can get the answer corresponding to each. So corresponding to the first function we have is this value, corresponding to the second we have is 0, and corresponding to the third function we have this value. And here are some special functions like gamma function and Bessel function. Okay, you can use for the special function also, and this will simplify these expressions for the special functions. Okay, so the corresponding to the first value, first expression we have 0, and for the second expression we have this value. And similarly, this is the last example. Here we can simplify symbolic function by using simplify. So this is the same. Here is fxy is equal to exponential x, exponential y, and simplify. See here, f23 and display f. See, the value is exponential 5. So simplify function also can be used for the symbolic functions. Okay, and then we have maximum, minimum, and point of inflection, asymptote. In this file, you can find the expand. So all the files are ready, just you need to use all these files. Okay, so here is the expand function. Okay, expand function is used here for x minus 1, x minus 2, x minus 3, and for this expression, both are the polynomials. Okay, and display function is used here to display the output. So the both have the same value. Both have the same value, you can compare. And here we have the expand function we are using for exponential x plus y product x plus exponential x minus y. So when you will use the expand function to simplify this one, and just you need to run this section, and after simplifying we will have this value, and you can use for the logarithm function. Okay, here you can expand the logarithm function, expand log a product b product c, and a, b, c are positive. Okay, see, this will be equal to log a plus log b plus log c. So all these are very simple examples, and you can expand this cosine cos x plus y. You can expand cos 5x. You can expand this value. So these are several few examples are also there, and you can use for the same. Yes. So see here, and also you can see here I am using the display function, and parallelly I am using the pretty function. You can see pretty function is there. So corresponding to these two inputs, we have these two output. For the first we have in this way, and for the pretty function we have this expression. Okay, so when you will use pretty function, this will return in the symbolic form, and you can compare these two output also for the second example. Okay, so this is this expression due to pretty function which we are using here. Okay, now we have the I will not explain about the what are the point of infection and what are the asymptote. We all are familiar. Okay, so here you can say functions have been written here. Okay, so here you can see asymptote to find out the asymptote. This is the numerator, which is 3x square plus 6x minus 1, and this is denominator, which is x square plus x minus 3. F is a function is equal to numerator upon denominator. So this is the numerator and this is the denominator, and f is the function. Okay, if you want to plot this function, this is very simple. You can use f plot. We need not require it to give any input for x variable. Okay, just you can use f plot as we discussed for the symbolic function. So this is the symbolic function, and we are using here f plot function. Okay, along with the first I need to comment all these statement here by control R. Okay, so only what will be there, this graph will be plot when I will execute this sequence of statement. This is the graph. This is the graph which you can see for the our function. Okay, and along with if you want to insert here, you can use grid on. Okay, so first I need to uncomment these statements. For the uncomment, you will use control U. For the uncomment, you will use control R, sorry, control T. By using the control T, you can uncomment, and by using the control R, you can comment. Okay. So now we need to uncomment this one also. Uncomment this one. Okay. So we are including here f1 is equal to minus 13 square 1 by 2 minus 1 by 2, and f2 we have is this one. So these are those points at which the function is undefined. Okay, so to the mathematically, so what you will do, plot the function by using f plot, and function automatically shows the horizontal asymptote. Okay, and to the mathematically find the asymptote of f, you will use this statement. Okay, and after that you can check the limit f to infinity. The limit as x approaches to negative infinity is also 3. So when you will execute all these sequence of statement, you will have the graph, and you can see the asymptotes in this graph. Okay, horizontal as well as the vertical. And at this place, we have the point of inflection. Okay, you can see in this graph, we are plotting the point of inflection. And for that, what we have to do, this is the numerator and denominator, the same function we have is at this place also, f is equal to num upon denominator. And we will simplify f1 is equal to diff. F1 is equal to diff f. First, we will differentiate with respect to x, then simplify by using the simplify function. F1 is equal to simplify f1. and we are using here pretty F1. Then again, we will differentiate F1 and we have F2. Okay, so we will solve for the point of inflection, and F2 maximum degree is 3. Okay, and double, in fact, these are the statement to get the point of inflection. And then after IDX, this will be the image double inflection point is equal to 0. So this will convert for the imaginary point, and inflection point to plot the to store the value from this place. Okay, in the inflection point. Then we are using here fplot function to plot, and we assign the range also -9 to 6. This is the range for x. Okay, and along with the this will plot the graph, but we will put we want to show the point of inflection also. Okay, for that you will hold on and hold off. This will control, will include the this graph in the same in this side. Okay, so this graph and this graph will appear together. So here we have the input for the plot. Okay, and subs f inflection point, and the color is R0. Okay, so the corresponding to these values, we have the point of inflection that will appear in the graph. And when you will execute, yes, so this point is the point of inflection. This is the point of inflection. Okay. And these are the same examples, and one is maxima minima. Okay, sometimes if you need to find out the maximum value and minimum value, that also we have possible, and you can use, and many times we need for different type of computings. Okay, so here you can find you can have the same equation. In the numerator we have 3x square plus 6x minus 1, and in the denominator we have is x square plus x minus 3, and this is the same function. You can see here at this place we will solve. Predicate function is used. You can do or not required. Okay, so here we want to find out the critical points first. Okay, for the critical point you just solve the f1. You will have the critical point. Okay, and then after what you will do, this is the plot of the given function. Then after we want to plot this critical point for the critical point. So double critical point, and you will use here double subs f critical point. So these point will appear in the graph. See, we want to find out the critical point for the above expression, and the title is maximum and minimum of f, and this is the text local minima and then local maximum hold off. And you are already familiar about hold on and hold off and its use when we combine the two graph in the single. In that case we have to use hold on and hold off. So there are two graphs, one is for f and other is for the critical points. Okay, for this one. So when you will execute all these sequence of statement and run the code, and you can see, you can find this is the local minimum and this is the local maximum. Okay, so for this part we have this is the maximum value and this is the minimum value, and this value is known as local minimum and local maximum. Okay, so in this way you can find out the local maxima and local minima. So this is all about the today's session, and all the content which I prepared has been presented, but along with I have some more content, and you can Just 1 minute. I have to close this file. Along with what is there, I have these 6 slides, and all these are related to symbolic mathematics, but during this small 2 hour, not possible to cover all the content, but only first and second I try to cover along with the some MATLAB codes. Okay, but for more detail, if you want to cover all the entire, you can go to here in the YouTube and search here. You can search here. This is the live streaming which is ongoing. Okay, go to the playlist, and inside the playlist you will find this one, MATLAB tutorial series 2023. Okay, and here you can find all the lectures: introduction to MATLAB, 2D, 3D plotting, operations, functions, control flow, which we have covered during the past. Okay, and this is session for the symbolic math toolbox. Okay, there are 6 slides and 6 lectures are there. Okay, so all the 4 lectures are there. So in the 4 lecture, we cover entire symbolic mathematics. Okay, then there are some more lectures are available. There are total 16 lectures, which will help you in the MATLAB, and the content are same, which we are presenting during this session also. So this is all about the today's session. If now there is any question, please feel free to ask me. Yes, please. Any question? From your side, you can unmute your mic, or you can put your query in the chat box.
Thank you, sir. I will try some programs and then I will ask.
Nearing simulation of
Isab Bala, your voice is not properly audible to me. So I think the content which we share with you, you go to all the contents of the past session.
I will download, yet not download.
Okay, so all the content has been shared with you, and also the content which I present in this session, along with some few are more content which I will upload for you. So for the tomorrow, you must cover all these content, so that this will help you for the numerical methods which we will cover in the coming session. So you must try all these content, and in the very less time you can do, and you can try all these content yourself. Still, if you have any question or query, please feel free to discuss with me.
Hello,
Yes.
my name is Muhammad Abbas from Borno State University. My question is, to comment, you use control R. What do you use for uncomment, to uncomment?
Control F.
Control R to comment in MATLAB. To uncomment, to comment, to uncomment, what do you use?
I don't get your question. Can you put it in the chat box?
Okay.
Control T. Control
Hello?
T will be the Control T will be used for that.
Control
Mohammed
T?
Abbas,
Yes.
Control T to uncomment that.
Okay, thank you, sir. Thank you. Hello, Doc. Hello.
Okay. Yeah. Control T and Control R.
Okay,
Yeah.
okay. Thank you. Thank you.
Comment, Control T for uncomment.
Yes,
Thank you
yes.
very much. Thank you
Yeah.
very much.
I hope it is clear. Yeah.
Hello.
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 Yes,
Exactly.
yes. Please, I want to ask: is there a difference between Sims and Sim? Sims and Sim. SYMS and SYM.
Sim. The Sims.
Yes.
Okay. See. Okay, my MATLAB is off. If you want to declare one variable, you can use y is equal to sim y. Okay. And if you have
Okay.
more variables, then you can use sims.
For multivariable sims and single one for
For
sim.
multiple variables. This is my window.
Hello.
Yes. Just 1 minute. Window is opening. Okay. So here you can see y is equal to sim, and then y enter. Okay, y is equal to y. So this is y is equal to y is a symbolic variable. And now you can use sin y. Okay, this is the assignment. Y is symbolic variable for y is equal to y. Or if you are declaring more variables, sims like x, then y, then z. Okay. At this place, you can declare only one, but here you can use multiple.
All right, sir. All right.
Hello, sir.
Hello.
Hello, sir.
Hello.
Hello.
Yes, I can.
Can you hear me, sir? Yes, can you hear me, sir?
Yeah.
I say in one of your example, you use pi. Pi is an inbuilt function, and you use pi equal to. Is it allowed? You use pi equal to some functions, and I know pi is an inbuilt function. One of the problem.
In the present, we
Yes,
have
pi
used pi as
equals to an expression, and the pi is an inbuilt function. Hello?
yes, yes, I can listen to you.
I say one of your example that you presented, you put to pi equal to square root of something.
Phi is used for the symbolic for the
Okay.
assignment variable.
Oh,
Okay,
yes,
that is not some specific function. Okay,
okay.
that is only the assignment variable phi phi,
Yes.
which was used for the golden ratio.
Oh,
Okay, you can use A, you can use B, or you can use a single assignment variable. But for that, I use there phi phi.
Okay. No, instead of p, oh, sorry. Okay.
Yes, this is only the symbolic. This is only the assignment variable.
Okay. The second is can you further expatiate about this? Simplify. The function simplify that normally return to 0. The simplify function.
Simplify function.
Yes, that normally return to 0. When you simplify, you get 0. Can you shed more light on it?
I don't
For the
understand.
use of function, that function is simplify, expand.
For example,
it says simplify, then you give a function maybe x squared plus y plus 2 by x plus 1, then it returns to 0. You gave example of something like that before. There are some example you give previously that the function, the result is to 0 when you use the function simplify.
I don't catch your question. In which manner you want to ask? Sorry, you can text me or you can write properly with example. Okay, tomorrow is also my session. You can send me through WhatsApp. I will consider for tomorrow.
It's okay.
Any more question, please? Yes, you can send me on WhatsApp by writing properly. And I will consider for tomorrow. Tomorrow is also my session.
Okay.
So I think no more queries are there. So thank you, sir, for such a nice and informative and useful talk. It will be very helpful for researchers and professors who are looking to explore the math lab in their study. Thank you, sir. Thank you once again.
Thank you to all. And tomorrow we will start at the same time as per our schedule, according to Indian Standard Time, 2 p.m. Thank you to all.
Thank you. Thank you.
Check it, it's 2 p.m.
Oh my.